Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with a very important topic of IITJEE Advanced, that is spectrum of hydrogen atom. Now we know that whenever the electrons absorb energy and then when they go back to their lower levels, that is the lower energy states, radiation will be emitted. Now when electron that is the electrons of a sample has already absorbed some energy, and after that when they are dropping to the lower levels they will be emitting the radiations. This spectrum is known as emission spectrum. It is just the opposite of absorption spectrum. Now if we take a sample and through it if we pass some radiation, we see that certain wavelengths of light will be absorbed by that sample, leaving some dark spaces. These dark spaces will be against a bright continuous background. So this will give rise to absorption spectrum because certain wavelengths have been absorbed. Now in case of hydrogen spectrum, based on the wavelength that are seen, we can have an equation. The equation states 1 by lambda is RH into 1 by n1 square minus 1 by n2 square, where n1 is the lower energy state and n2 is the higher energy state. In this equation, R is Rydberg's constant, whose value is 109678 centimeter inverse. Depending upon the higher energy level to which the electron is jumping back to the lower energy level, we have some series of lines. If the electron jumps back to first energy level from any other higher level like 2, 3 or 4, the series obtained is termed as Lyman series. It falls in the spectral region ultraviolet. If the lower energy state is N2, n equal to 2, it means the electron is jumping from any higher energy level like 3, 4 or 5 to the second level. We get the Balmer series. Balmer series falls in the visible spectral region. When the lower energy state to which the electron is jumping back is 3, from the higher energy levels like 4, 5, 6 and so on, this series is termed as Paschen series and it falls in infrared spectral region. The next in this series is bracket series, in which the n1 value is 4, that is the electron jumps back to the fourth energy level from the 5, 6 or 7 n2 values, again giving this bracket series in the spectral region infrared. Fifth series is Fund series, in which the lower energy level in which the electron jumps back is 5th from 6th or 7th or 8th energy levels. Here also the spectral region is infrared. Now in this case we find that whenever the wavelength is less, we know that delta E, that is the difference in the energy levels, and this delta E will be the energy which is either absorbed or released, that is given by hc by lambda. So shorter the wavelength, more will be delta E. When lambda is maximum, that is when the wavelength is maximum, delta E will be minimum, that is the energy change, the energy gained or lost, that will be minimum in that case. When we get the first line at that time, n2 value is n1 plus 1, that is the lower energy level plus 1. If this is the case for n2, then it is called as alpha line. This is the first line. Second line is called as beta line. In this case, the second energy level, that is the higher energy level, can be given as n1 plus 2. The limiting line or the ultimate line is obtained when n2 is infinity, that is the higher level is infinity. When n2 is equal to infinity, it is the shortest wavelength, because we will see that the energy will be high, energy difference is high, delta E will be very high. So pertaining to it, the wavelength which is obtained will be the shortest wavelength. So in this situation, if we know delta E, we can calculate the wavelength for that particular radiation. Using the formula lambda in angstrom is equal to 12400 by delta E EV, electron volts. Delta E is given in electron volts. Based on these concepts, we can solve some numericals. Let us see. First is, if energy of the electron in hydrogen atom in its ground state, that is the electron is in the lowest state, that is the ground state, this energy is 13.6 eV. Then what will be the energy in the first excited state? Now we have to use this formula En equal to minus 13.6 Z square by N square eV. We know that for hydrogen Z equal to 1. And it is in the first excited state. So first excited state means N equal to 2. For hydrogen Z equal to 1. So E2, energy in the first excited state, will be minus 13.6, because Z square becomes 1, this value gets 1. N square is 2 square, that is 4. So it is minus 13.6 by 4. If we calculate, we get minus 3.4 eV. Next in the line, if we see a similar type of numerical, how much energy is required to move an electron from the ground state of the hydrogen atom to the first excited state? That is ground state to first excited state it has to go. Ionization energy of hydrogen atom is 13.6 eV. Now ionization energy is 13.6, so E1 is minus 13.6 eV. E2 we just calculated in the previous numerical, so E2 is minus 3.4 eV. So energy required is the difference in these two levels, that is minus 3.4 minus of minus 13.6. So it comes out to be 10.2 electron volts. Next we can see something about the series we have just studied. The Lyman series in case of hydrogen spectrum is given by nu equal to 3.2881 into 10 to the power 15, 1 by 1 square minus 1 by n square. We have to calculate the maximum and minimum frequency of lines in this series. Now see, we know the general formula is 1 by n1 square minus 1 by n2 square. Since it is Lyman series, first series, so n1 is 1. So we take it as 1 by 1 square. Now in this we see frequency will be maximum when n is infinity, because in that case frequency will be maximum when delta E is maximum. So for that n should be infinity. So if you, in place of n, if we put infinity, we get nu max as 3.2881 into 10 to the power 15, because only this will be left out. Now if we go for the minimum value of frequency, we find that frequency will be minimum when n equal to 2, that is it has just jumped to the second level, because now 1 by n square in this case will be maximum. So when 1 by n square is equal to 1 by n square is maximum, we get the minimum value, that is 2.4661 into 10 to the power 15 s to the power minus 1. So this was V max, this is V minimum, frequency minimum, minimum frequency nu. Nu minimum is 2.4661 into 10 to the power 15 S inverse per second. Thanks for watching my video. Please subscribe to my channel so as to stay updated with the latest videos which I will be uploading. Thank you all very much.